Dun, dun. I think we should start. Perfect. So we are back then with Dr. Hayley King, and we are going to talk about plankton, polar orbiters, and Python.
Shared right. There we go. Okay, thank you very much, and thank you for having me. This is the first time I've been involved in a Python-based meetup, so I'm very, very pleased to be here and to be able to share with sort of maybe a slightly different community than I normally talk to. So hi, I'm Hayley. I work for an organization called UMetsat. You may or may not have heard of us, but you will have certainly seen some of the work that we do probably every single day. So UMetsat is the European organization for the exploitation of meteorological satellites. So we run all the satellites that provide data for the weather reports and forecasts that you get every single day. That's one thing we do, but we also operate a variety of other satellites for different purposes. So not just weather, but also looking at climate. And in my case, which is why I'm here, we also operate satellites that look at our oceans. So in my background, I'm actually not really a space person. I'm a marine scientist by background. I've studied the ocean for the last 10 or so years. However, I now live miles and miles and miles away from the sea. I'm based in Darmstadt, which is pretty much straight in the middle of Germany. So I'm about as far from the sea as you can get. But I'm hoping to convince you with this talk that between a polar orbiting satellite and some Python, that you can also observe the sea from wherever you are in the world too. You don't actually have to be a scientist sat next to the sea or on a boat to study it. So everything in this talk most of it is through a program called Copernicus, which is from run by the European Commission, of which we take part as UMetsat. But space is really a team sport, and we work a lot with different partners, the European Space Agency, who I'm sure you've heard of, and various other partners all around the world to make these missions and data kind of products and services happen. So big thanks to all of them for the content that I've rather shamelessly stolen in this talk. Okay, so I wanted to start with this picture, which is not a picture from space, and it's a picture that still to me is a little bit absurd. So these creatures, if you've never seen them before, are plankton. Their name comes from an ancient Greek word which means to drift. And they are literally just a group of different species of creatures, some more plant-like and some more animal-like, that live in every single drop of seawater all around the world. And they're very, very important. They are the basis of our marine food web. So anything you eat from the sea has these guys involved at some point. They produce around about half of the oxygen that's in the air that we breathe. And they do a whole load of other things, but I'll tell you more about that in a minute. Anyway, so this is plankton. This is one of the things I've been studying a lot over the last 10 years. This is pretty much the same picture. You'll have to take my word for that. This is it is the same picture, but it's taken with a very different set of eyes, different set of instruments, and from very, very far away. So the image you see here is what we would call ocean color. It's a combination of measurements of different wavelengths of light measured by a satellite called Sentinel-3. There are two of them. The company I work for operates them. They fly around above our heads and they scan the Earth and collect images such as this. And the green swirls that you see in this picture are the impact that you get when you have enough plankton in the water to change the color. They actually change the color of the water all over the world. You've probably seen it with your own eyes. Some places you'll have been, the water's very, very clear, maybe somewhere nice in the tropics. If you've been down around the coast of Ireland or in the UK, you've probably seen it's much more green and murky. Phytoplankton are one of those things that live in the sea that change the color. And the reason they change the color is part of what it is that makes them so special. So they photosynthesize like plants on land, and they absorb light. And this interaction they have with the light field is what makes us able to observe them from space. So to me, it's completely absurd, this idea that these microscopic creatures that you can't see with your eye, you can actually really capture in this incredible way from space. So yeah, this image here is from Sentinel-3. It was taken last summer, just after the massive heat wave we had in Europe. There's particular species of plankton that are involved in this big bloom we see here are called cyanobacteria, and they typically proliferate when we have very warm conditions and the sea is very stable, allows them to grow and grow and grow and grow. They can cause problems. They accumulate near the coast, they can harm your lungs and things like that. So very interesting phenomena and very beautiful, I'm sure you'll agree. They're not always so beautiful. This is quite an interesting picture and case here. So this is the coast of Southern Africa. This is where I did my PhD. I studied at the University of Cape Town, which is just around the corner from where this photo was taken. The photo's from a helicopter, not from a satellite in this case, but we did actually look at this phenomena with satellites as well. And you can see that big red streak in the water there. And this is the same sort of phenomena as in the previous picture, where we have phytoplankton of a certain type that are causing the water to turn red. And these blooms that you get here, like this example, are very common along this coastline. And they represent a huge amount of growth in the water. And eventually these creatures run out of food to eat, and they all start dying off. And when that happens, they start decomposing. It's basically kind of like a compost heap, if you've ever been near a compost heap, and you get that really awful smell. It's from these different bacteria that are degrading everything that's there. It pulls all the oxygen out of the air around it, and in the water does the same thing. You end up then with these big swathes of the coastline that have nearly no oxygen in the shallow bits of the water. And the picture you can see inset here is when this has happened, and a whole coastline's worth of rock lobsters have just had to walk out onto the shore because they've got no oxygen left to breathe. These are an important fishery for this region. As you can see here, this gentleman's not letting them go to waste. So these phytoplankton also have these really quite bad impacts on our environment as well. In this case, what happens is totally natural. It's related to the ocean circulations in this area around Southern Africa, but it can happen as well as a result of influxes of things like fertilizer from the coastlines from our activities such as farming. So this is an animation, a collection of satellite data, and I wanted to sort of show you this just to give you an impression of how complex these systems are and how the changes in color vary with time. And this is 10 years or so of data, but also all around the world. You see very different activity going on in the coasts versus in the middle of the ocean. You can see the seasons quite clearly. I think when the Earth turns around, you'll start seeing sort of seasonal cycle as we get light in the northern and southern hemispheres, respectively. There you can see it going up and down. And this really should just give you an impression of how complex the oceans are and how hard it is to observe them fully without this kind of picture. You imagine taking a boat out and trying to take a measurement at any point in this map. It would be impossible to have an idea of how dynamic it is in space and time without something like a satellite to capture that. So that's what we do. We use satellites. This one you can see here is again Sentinel-3, which is kind of my favorite one, I guess. It's the one that I work with the most in my job. And it scans the Earth, as you can see here. It measures the different colors of light that are being reflected back at it from the sunlight. So it can only work during the day and it can't see through clouds. And you can see that it captures all this information. It's what we call a polar orbiting satellite. So it goes around and around the Earth over the poles. And the reason we have it in this orbit is so that we can take advantage of its position to make the optimal measurements that we need the light for, and for various other things as well. You get different types of satellites. This is a polar orbiter, as I said, but you also get geostationary ones. These sit at a certain point and just stare at the whole Earth disk. We use these a lot for weather forecasting. There's one that we operate that sits above Africa, and you can use those satellites to take measurements much more regularly in time, but you can't cover the whole planet with them. So we trade off with the polar orbiters, and we have two of these ones that are in this particular animation, two Sentinel-3s, and they orbit all around the Earth, and they can cover the whole planet in about 2 days. So we get every point on Earth basically gets imaged every 2 days at least by these satellites. The further north you are, closer to the poles, the more frequently you get the measurements. So get a bit of benefit if you're in the northern hemisphere as we are, and the same in the southern hemisphere towards the poles. It's not just the color and images that we can measure with satellites. So we have a number of different ways of measuring different things about the ocean and land and the atmosphere as well, but I'm mostly talking about the ocean here. Three main areas that we work on, and these are all represented on the Sentinel-3 satellites that I work with, are altimetry, which is a form of radar, and then two optical types of measurements, so the ocean color, which you've just seen, and sea surface temperature. And the reason we make these measurements is this data can have a huge number of applications that are really relevant for people all over the world. You can see in the diagram here just a few of some of the example applications. Some of them you may not be familiar with, but things like supporting fisheries, monitoring coral bleaching, understanding climate change, weather forecasting, making sure that our shipping is safe. You can see on the left there some examples of rogue waves, of ships that have had issues running into ice. We can monitor things like illegal fishing and oil spills as well. So the satellites really are a toolkit for addressing problems we have here on Earth, even though they're up in space. But we have a bit of a challenge. We have huge volumes of data, somewhere in the region of 50+ terabytes per year from sort of one of the Sentinel missions which we're running. At the moment, there's 4. There will be probably somewhere in the region of 15, I think, in the next sort of 5 to 10 years of the missions. And usually they're flown as multiples of satellites, so we get good coverage. So basically a huge amount of data. And on the right here, you can see the sorts of people who may need to use this data. And well, I'd invite you to think about how many of those people have the capability in terms of skill and infrastructure to be able to manage 50+ terabytes of data every year. I mean, I think Angela Merkel's doing a fairly good job at the moment with her particular profession, but I'm not sure how good her programming skills are or what sort of computer she has. So there's a big challenge in actually getting the data down to people who could benefit from the information it can provide. And in reality, there's a huge number of people that are involved in between. So this kind of summarizes just the diversity of people who work in the satellite, like Earth observation field. On the right-hand side, you have the people who are like me. We operate satellites, that's our job. At EUMETSAT, we don't launch them, we don't get the fancy rocket launches, we leave that to our colleagues at the European Space Agency. But once the satellites are up, we make sure they're operating day to day and we send the data out. That goes downstream to many expert users, people who work at universities in specific research facilities who have good experience working with Earth observation data, probably people like Nicholas and the company he was working for. And they work with this data to make sure it's accurate and to derive new and interesting information from it, and also to inform back up to us what we should be doing in terms of calibrating our instruments or new sensors that we should be developing. Moving downstream, they work particularly with experts in different fields, so maybe in the insurance industry, maybe marine biologists who can say what this information can tell them about the environments that they work in or the sectors that they work in. But still, that data is inordinately complicated and it's got to be communicated out at some point. And this is where sort of developing services and tools to view and analyze data is really, really important. And we're seeing a huge growth in the kind of number of experts from different disciplines, app developers, software developers, people working on WebGIS, etc., who are getting to grips with this data and helping to get it out to people downstream who can use it more. And at the end, we hope we have an impact on different sectors. So there you might have everybody from, there's a lady here on a beach, what she stood amongst is sargassum seaweed. This is something that occurs naturally in the oceans and floats around, but occasionally ends up on land and absolutely devastates the tourism industry in different places. Knowing that it's coming means that areas can put booms across bays. So one thing that remote sensing can do, or Earth observation from satellite, is say when this is coming and get people prepared so they don't wake up and find this on their beach in the morning. We also obviously contribute lots of things like policy. So the IPCC reports and various different pieces of environmental policy are increasingly becoming informed by the sorts of information that comes downstream through this process. So why Python? What does this have to do with Python at all? Well, Python really is a tool that is now embedded throughout that entire value chain that I just showed you, from the very top in organizations such as mine all the way down to the end users who may not be working with Python themselves, but they're certainly benefiting from tools that are based in Python based language and software, etc. So at the system level, the things that we do, operating the satellites, running the ground stations, processing the signals into meaningful information, runs with Python. When that data is produced, it needs to be managed in databases, it needs to be able to be searched. We use a lot of APIs, etc., and a lot of that is Python based too. Downstream scientists and various other users need to analyze data. Python is becoming an increasing tool amongst that community, although perhaps not as quickly as some of us might like in different parts. So this is something I'm working on at the moment. Data needs to be visualized in some way. These data, as I said, are huge, so you have to change them, summarize them in different ways, whether it's an image like the one behind me or in terms of some sort of time series graph or something like that. It has to be manipulated and visualized, and it needs to be communicated, and that's where that really comes to the fore in terms of app development and web development, where our visualization, our data capacity meets, and Python is a really great tool for us there as well. The last point I think is very important here as well is that science that we're doing, especially in the Earth observation sector, is increasingly open. So I've mentioned the Copernicus program. This is the missions or program that I work on from the European Commission. And it has a very strong open data policy. So data is freely available for everybody all over the world for whatever purpose you like. You can go and download the data and use it, build a business off it. It's free and open. So I think naturally kind of Python and open source software and principles goes together with this very well. And it's a tool that we're using increasingly to help more people access our data and benefit from it. So it's really a tool that is used across this sector. I can't explain enough. I mean, there are people who are way, way more capable of Python than me who are working, for example, in our systems and processing, but all the way down to the scientists and sort of new users are also using Python now more and more because there's so much available to support us in our work. So how am I using it now? Well, I am ashamedly, I guess, slightly an ex-MATLAB person. So this is what the oceanography community has historically used. That's what I was taught during my master's degree, and I hated it. It really sucked. I did not enjoy programming at all. It did not come naturally to me in the slightest. However, I'm pleased to say that's probably changed quite a lot now, and I actually really enjoy a lot of the programming I do since I've moved over to Python. I find it much more sort of intuitive to use and just a much wider range of possibilities. I worked in South Africa for some time, as I mentioned, and this really impressed upon me this need for open source. Data as well has gotten so much bigger that a single kind of limited technical programming language is not really sufficient for those of us working in Earth observation. There's a lot asked of us as scientists working in this field now. You know, we have to know more about things like working with databases and doing large, efficient processing, which is not something that was necessarily asked of scientists a long time ago, and we don't necessarily get trained in those sorts of skills as we go through our careers. I've spent the last part of my PhD reprocessing a 10-year archive of data to understand why these red tides that you saw in the previous picture, the harmful algal blooms, occur. And in order to do that, I needed to interface with a high-performance computing system, which I just could not use MATLAB for. Licensing would have been prohibitive, so I had to learn Python pretty quickly to try and get to grips with that. And the challenge I have now, which relates to the job that I do, which is very much interfacing between the organization I work for who operate and develop the satellites and the users downstream, is supporting the next generation of users and the people who will come and work in organizations such as ours. So we're really using Python a lot now as a training tool for scientists to help them work with our data. We rely a lot on various things like the NetCDF libraries. We use a lot of Xarray. We work with a huge number of visualization and sort of image manipulation libraries, things like GDAL, CartoPy, various different mapping libraries and tools. We're also, as I said, because of this open data policy, really pushing to encourage our community to use and share more things openly. We're even down to things like the data that we use to double check the quality of our satellites. It's now as part of our standards that you have to provide the code you use to process your data, so other people can openly see it and review it so that we can ensure its quality. And you can't do that unless you've got something like Python that you can do that in. And also, I'm trying to do a lot more to let kind of expert programmers know about our sector. As I say, this is not something that is kind of my core skill. I used Python as a necessary tool. I'm definitely not a computer scientist, certainly not by training, but we need more people who have those skills in our sector. So I'm doing a lot to try and reach out to different data science communities to let them know that these are the sorts of fields they can work into. There's lots of cool Python related things going on in our sector at the moment. Myself and some colleagues recently had a chat. This was a week before last, and we started gathering a whole bunch of different tools and libraries and code that people have been publishing on GitHub in this collection here that you can see at the link. This will soon be added to by a repository that I've been working on in UMetsat to share all our training code and tools and outcomes from our science studies. As part of Copernicus, we run a huge amount of hackathons and data visualization competitions. That link there is just one that you can check out if you'd be interested in working with our data and putting some of your Python skills to other use. I can really encourage people to do that. I always learn a lot from these hackathons because people come with very different ideas and experiences that I would not necessarily have thought about. So I would highly encourage you to have a think about that. The last thing is, if you're really interested in learning more about Earth observation data itself, we run training courses, as do many of our colleagues, and you can find out about some of them at the link there, the training.umetsat.inc one. Most of them are focused from my side on the ocean, but we also do things on climate and on atmosphere and on weather. And a lot of these are openly available. There's funding available usually to come and join us if we're doing them in person. Obviously, with the situation we're all in at the moment, this is not something we're doing so much, so most things are online, but we are still going and still running training. So with that, I'll leave you with a very nice image taken last week of Ireland with Sentinel-3, and thank you very much for your time. I'm happy to take any questions, and you can contact me either through this email or on my Twitter as well. Thank you.
Thank you. That was amazing. I love the picture, by the way. The picture is, it's so cool. Cool. So does anyone have questions, guys? All the questions that came up to my mind, you actually gave the answer straight away. So yeah, just take that as a really well done job.
Thank you. Thank you. I'm glad you enjoyed it.
How does the training work? Like, do you guys do like, do people sign up for it and then you do like small courses, or you do by tasks? How does that training work?
Yeah, so we run various different things. The main courses we do sort of twice a year are blended courses, we call them. So we have an online phase where we use a platform called Moodle, which serves as like kind of a front end really. You can go through then and read about the satellites, about the data and how it works, from a scientific perspective, about what formats it's in. We also help, it has videos, it has interactive tutorials and things like that. We help people to register to use the data. We show them the basics. A lot of people come to our courses and have never done any programming. So we have this challenge quite often of getting them to start with Python, which is a challenge I really enjoy, because I think a lot of people can be a bit nervous or a bit put off by it, think, oh, that's not something for me. But we usually get people running code quite well by the end of the course. So that the online phase sets them up for that. And then we have these classroom phases, which are typically a week, where everybody comes together. And we are quite unusual in that we don't do anything like traditionally in terms of lectures and things like that. We very rarely stand up in front of a PowerPoint and talk. It's all interactive, and we get people to kind of self-define a project they want to work on, and then we help them. A lot of this is based around a code repository that we share, which has lots of examples of how you can download data in batches, how you can visualize it, how you can make it interact with other bits of software to derive other information and things like that. And then by the end of the week, we have people present back to us something they've investigated. And that can be anything. We've had people who've done oil spill detection, who've looked at building a system that would regularly get sea surface temperature data to stream to little information centers around beaches in this was in the Baltic Sea area. We've had people look at whether they can use this information to help define where they should put marine protected areas, or where they should guide fishermen to go to minimize their fuel costs. all sorts of different projects. You know, some people just work on very like kind of data heavy processes. So they do things like large scale visualization or incorporation into web portals, or about managing their own archive if they work for like a big data center, like one of these national data agencies or something. So it's really a very diverse range of people who come to our courses. And I like that, because we bring people together from these different backgrounds as well for them to exchange ideas. So they're open applications, so anybody can apply. You have to write a motivation. Yeah, it's pretty open in that sense too.
Wonderful. Well, so that's a chance. And for everyone that enjoyed Hayley's talk, you can join her as soon as this is all over. We can all join.
I have a question. I don't know if I'm cheating because I have the microphone, but then I would take advantage of that.
Go ahead. Go ahead.
First, cheers. So I'm trying to have the meetup feeling, so I'm having some.
Oh no,
wine.
I should have got some wine. I've only got water.
Yeah, I have water as well.
I was using water, but then do you have any open set of images that we can play with?
Yeah, I mean, you can literally access all the data that we've collected from these satellites since they were launched. So I can, if you go to here, let me write it in the thing for you.
I already knew the answer, but I was cheating.
Yeah.
But
no, it's a good point.
I think that's really cool because the Sentinel data is quite big.
Yeah. So this is just one example. This is the delivery, like the main delivery mechanism that we use for our data at Works. This is where you'd find the Sentinel-3 data, mostly marine stuff. As of today, there's also been, we've released some new products on looking at fires, which is quite interesting. So this you can access. You can use an API as well to access it. Yeah, that's just one. I mean, there's lots and lots of other different portals you can access this data to through as well. There's a really, really great one called Sentinel Hub, or you may have heard of EO Browser. That is it's by a company called Synergize. They have a really, really fantastic interface. If you don't want to do too much programming, but you just want to look at the images, that's also great. It has quite an interactive code-based backend though, so you can use it to do quite complex stuff. It's very cool. We've also been recently involved in launching a hosted processing system. So we are putting all this data into one kind of distributed hosted processing infrastructure, which will hopefully help people to access it more readily without having to download it all, because it's so big now that it's pretty impossible to hold it all yourself. So yeah.
Oh, cool. So we have a question here from Georgios asking, what type of libraries do you use for the visualization of data?
Hang on a minute. Where are we? Is this in the chat? I was just trying to see what was it they said?
That's in the Q&A. That's the
okay.
Q&A. Yes.
Libraries visualization of data. Yeah, so most of my stuff I use Cart2Py at the moment. That's the one that I use. I mean, it's basically Matplotlib in background, but I use that extensively because of the mapping functionality. It's pretty useful for us. But I'm always open to other ones if people have suggestions, because this is, yeah, something that I kind of use one thing and then end up using that for a long time. But then new things come along. We used to use, the kind of Matplotlib and base map combination, and base map we stuck with until it basically wasn't supported anymore, and then we've been forced to move to Cart2Py. We're not a very rapidly advancing kind of population, I guess, in science. Sometimes we tend to, we get something nailed down and we stick with it, which is bad. We should be better at that. So yeah, if anyone has suggestions for good visualization, I'd be very keen to hear them.
Perfect. I think someone is suggesting something on the chat right now.
Okay. Oh yeah, Rasteria we have used. Yeah, I have used it before. It's good. It's good. Yeah.
Perfect. And then I think Agatha is asking if you could send you the links of the services that you just mentioned. They are on your slides presentation, aren't they?
Yeah, there's some of them are on there. The data services aren't, but I can add them if you want. I'll add some more information on where to get actually access to the data and things as well. That's no problem.
Perfect. And then we share the slides with the presentation.
I think you're missing a question there.
Where? about?
So
I don't.
it's,
Oh yeah, the cyclones one.
Mm. Yeah, that's a really interesting question. So, I mean, we don't sort of annotate the data explicitly in terms of, you know, this is a cyclone, or this is you know, a specific one, but we do flag our data with kind of various indicators. So I mean, you have flags, for example, for different types of cloud, which could be useful in this kind of circumstance. I know quite a few people who've done some really interesting work on doing pattern recognition with the data to try and pick out things more regularly. It's something I did myself, not with cyclones, but with the blooms that I showed in the presentation. We were trying to you know, identify them as kind of like a blob in their own right, and then track where they go, because the movement had quite a lot of use for the fishing industries and the aquaculture to say where they were going to go and predict their movements. So that kind of image analysis, and there's a lot of work going on with machine learning to try and identify things more. It's not something we do routinely commonly at the moment, but I feel like that's the way that the sector might go. You might find that we do more of this kind of analysis ready data using machine learning AI techniques to identify features. It's a great question.
That was a great answer. Thank you. Perfect. So I don't think we have any more questions for now. Well, thank you very much, Hayley. That was very, very, very interesting. Thank you. And then, well, I think it's time for lightning talks now, but I let you guys go for maybe a toilet break again, or some water. Go stretch your legs.